So thanks very much for having me on the call. My name's Liam McGee. I'm Chief Scientist at Kaiasm, and we help organisations get their knowledge and people ready to interoperate in practical ways for a possibly AI-powered future. And we largely work with critical national infrastructure and manufacturing clients. And what we look to do is to bridge the gap between data mapping and interoperability and AI context. And we like to sort of bring lots of different sorts of data sources into a coherent knowledge base, hopefully something that can be seen as a digital twin of the organisation, which allows you to test out lots of what-if scenarios, things like that, amongst sort of a model of reality and processes and people that you've got for the company. We try and do it via kind of knowledge transfer. So we're kind of not really a consultancy model. We've built tooling to help people do these jobs, but we do kind of work with them to do it. And so what we're doing is to sort of lay the foundation of data systems which are accurate and explainable and scalable. And that are, to a degree, AI ready. But the main topic of today was really around interoperability. So while I will touch a little on AI at the end, I'm not going to do too much about it. So we identified a few kind of key lacks, I suppose, in the tooling environment, and so that's why we ended up building the tooling we did. One is that most people start from a fairly messy situation. So that would be with lots of knowledge held in different sorts of format. That might be in more formal modeling languages like enterprise architecture diagrams, things like that, or data models. But a lot of the time it's in possibly moderately documented databases, but lots of spreadsheets, slide decks and things like that. So we needed to make sure that we weren't being too definite about the state knowledge needed to be in before you could bring it into an environment to join it together. We also wanted to engage everybody, not just technologists, and we wanted to manage the different perspectives that you get both within an organisation and between them, and that any maturing of those perspectives or kind of dealing with disagreements, things like that, should be fully auditable, so you could see the change in meaning or the improvement of meaning and the removal of ambiguity over time to reach as you move towards reaching consensus. But you don't need to have consensus to make things visible and readable and easy to use for both people and machines. So we've done a lot of work with a visualization approach that looks to reduce the cognitive load, the kind of thinking load on the people using it, but keep all the detail under the hood for the machines. As I said, we work in various ways, but we're not fussy. We'll do it for people. We'll hold their hands as they do it, and hopefully get them to doing it themselves. So here's the tooling we've built, and I'll show you a little bit of that as we go. But one thing you should be aware is that while we don't necessarily talk about ontologies a lot, although clues in the name, Ontokai, it is all ontologies under the hood. So lots of RDF and things like that underneath, but on top what we're doing is trying to keep it reasonably straightforward, not require people to know the difference between a taxonomy written in SCOS or an ontology written in OWL, and the fact they're not quite the same thing, even though you've got a concept in one and a class in another. We don't mind too much about that. We allow people to join those things together and say, okay, for ease of thinking, they're the same thing. In machine language world, we might hold them separately. Back end of last year, Department for Transport invited us to do a bit of work for them. So Jonathan Eyre and Fabienne over at AMRC were creating an extension of the IES, the Information Exchange Standard, to allow for various transport concepts to be modelled, especially in road and rail, but presenting that to stakeholders as just sort of a text file as an ontology in Turtle or something like that wasn't terribly useful to the stakeholders. So we were asked whether we could visualize it and to help validate the developing model. Another thing you should also be aware of that we're very interested in understanding the maturity, interoperability maturity of both organizations and data sets. So here's a piece of work that we are working on with ARUP for Rail Standard and Safety and Standards Board, which is a way of understanding the interoperability maturity on a number of different dimensions of a data set. So this is a formal assessment, and it's looking at what are the main barriers to interoperability. It's drawn from lots of kind of sensible places like ISO 11354 and various European projects, things like that. And one of them is technological, so that's about physical connectivity. So are you sitting data on a mainframe you can't plug a network cable into? There's several organizational dimensions, 3 of them, around being clear on are people allowed to share the data and under what circumstances, what information is given around the trustworthiness of the data in terms of data quality and service level. How often is it released, and can you rely on it turning up at the end of an API when you want it to? And conceptual, so that's around, do we have agreed common formats or do we have agreed common meanings? And it's the semantic meaning that that the IES4 project and the multimodal ontology we're really looking at, because if you remove the semantic barriers to interoperability, agreeing what everything means and what parts of the real world we're actually modeling, that you may not need to worry about agreeing a common format simply because that as a problem goes away. There are ways of getting around it, which I'll talk about in a minute. So this one method of doing it is to build an ontology. The information exchange standard is one of these. And what's an ontology trying to do? You're trying to harmonize one organization's conceptual classifications and the real world things and their relationships that are being modeled with another's. Let's go through that one step at a time. So I just want to break it down. We think that the first step people tend to like to take, and this comes from our experience with clients like National Highways or Howden's Joinery in a retail world, is to start saying, okay, what do we call stuff? And can we look at the different classifications we've got for things, and can we make sure we've got more than just the label? So we like to get a definition in there. And a good definition is something that's sufficient to say, I've got an individual here and I can unambiguously put this in this class or not in this class. To help me with that, I might list acronyms, things like that, and other words people use. We're not fussy about what people call things. We just want to know what the things are and the labels that attach to them. So here we have like various names for cat, including words we don't use anymore and words in other languages. And another really, really useful thing to have in a taxonomy is both example members and non-members. And that becomes very useful later when people are trying to deal with ambiguity. But as an example, if you're trying to define the class of birds, you can say a lot of shared properties of birds, but bats share a lot of those properties, but they're not birds. A quick shorthand is to say, yeah, bat, example non-member, not a bird. That really helps. We've discovered large language models to get the categorization right. Typical things that would come into scope would be category hierarchies, file system hierarchies, naming conventions, breakdown structures, and so on and so forth. From a multimodal ontology point of view, it's what are the various names that different organizations are giving to these same concepts in the transport area, especially as you're moving towards how bus people see the world, how train people see the world, how road people see the world. That's one step on your maturity journey, but that's really just sort of agreeing your dictionary, if you like. The next one is what does it all really mean? So we're interested in documenting the set of real world things. So that might be objects you can kick, but also kind of concepts we hold like risks or events, actual kind of things that happen in space-time that an organization deals with. And importantly, how they logically relate. There's a number of various important logic relations, but causation is a really obvious one to start with, but also things that are a kind of something else, things that are a part of something else, things that are an individual example of a class. Plus a bunch of other relationships that you can put in. Also metadata such as provenance and ownership and status. So covers lots of different things, physical assets, as I said, but also regulations and policy and people. And it allows you to lift logical and business rules out of applications and into the data layer. Why? Well, for consistency, interoperability, common understanding, and removing risk and ambiguity. Ontologies are not just used for interoperability. At National Highways, we kind of listed a few different things that people were commonly using these kind of ontological models for. A map, what do we have, where is it? What do people call things in different parts of the business? Why are we storing this in the first place? What's the regulation or the license requirement? And how do I build my data models in a way that will save time and pain later? And then increasingly, and that's kind of right now stuff, is looking at comparing existing data sets with external standards, with information requirements, and also automation. How do you automatically lift data out of one model and drop it into another? So when we worked on the DFT project, the first thing to do was to take the ontology that Jonathan and Fabienne at MRC had developed and visualize it. And this is a fairly typical sort of visualization, this sort of network view. But what we like to do is to take that net and take a point on it and shake it out and say, if we're going to commit that everything's a sort of thing, for example, I want to be able to track that through. And it's much easier for people to understand things in a sort of tree shapes than it is in a complex network, especially as you start having more and more things. It becomes a way that we can pack down lumps of things into concepts that we can keep track of. So AMRC did the work. So the previous one was the kind of upper core, the IES standard at the top, which is meant to go through pretty much anything in, across the public sector. They built a transport core, which was things like classes of vehicle and the kinds of vehicle, the differences of vehicle in between them. And then more specific thing, this is one for road. Rail was another one, and road rail, and I think ports and airports coming soon. And the idea is, how do you break down things that are particular to road and bring them into a single view that you can unpack. So you can see we've got, so vehicle at the previous level, we have passenger road vehicles going down to category M vehicles, 10-person vehicles, and then nasty things like a 24 vehicle is apparently a kind of 10-person vehicle, because when we say 10-person vehicle, we actually mean 10 or more person vehicle. And those are the sorts of ambiguities that can bite you if you don't have nice, clean definitions. And then we hang it all together. So this is where you have things at IES4 at the top in bright pink, things that come from a number of places, go stripy, and then we're down into the road section. We filter to areas of interest, we look at individual definitions, as you can see, we can see what the source is, and then we allow stakeholders to view it and comment. So you can see one here for road vehicle. Tessa has noticed that inclusion of number of axle numbers can aid matching to some data sets. And other questions we had is a pedestrian a self-propelled vehicle? And this is what you call an asset, it's not what we call an asset. In the end, we ended up taking a lot of lessons from how e-commerce websites organize their information. If you can go from a net to stable explorable trees, you can hold the net underneath, but they're much easier to navigate, easier to remember, and you start using things like consistent color for navigation. So a particular source always has the same color, and you can also have different sizes for things that are more valuable, more important, have a greater count of things that you're looking after, and so on. We brought it out to people and we validated it, and that was fine, but we saw that there was quite a serious next problem, which was joining the data. So people wanted to know how they use the ontology. So it's all lovely, it agrees with our view of the world, but why is it useful? At the moment, if you're mapping between data sets, you have to do one-to-one mappings, typically between the data sets you want to map between, and that can grow to quite a large number of mappings. If you have an ontology in the middle, if you map a data set to the ontology, that for free gets you a mapping to all of the other data sets mapped to the ontology. It's a slight oversimplification, but it does massively reduce the amount of work you have to do to keep things up to date and in harmony. So we decided to bring the idea of a data source as well as the idea of an ontology into the Ontology system and say, I just want to say that expertise over here in the ontology is represented in expertise as a table of the database over here. Expertise in the database has an ID and a label against it, and we can start building up a map. So this is how it works. You have a data set which takes information from an ontology about what classes or properties it's representing, and you build an artifact called a triples map. The triples map says, how do I take information out of the data set using classes and relationships in ontology and split that out as a series of facts, simple facts called triples, which are things like Liam is an employee of Kaiasm. So nice and straightforward things. That's about as simple as you can get. You can recompose them back up into tables into another data set, as long as you've got that mapping back, so you're sure that you're comparing apples with apples. So if that's the data source and that's the ontology, this gray area here is the triple map, and then you just have to do the knitting. Once you've done the knitting, you should be able to automate the lift and the drop from one data model to another. Just as a little bit as we come to the end of the presentation is to say, once you start agreeing an upper ontology like IES, a domain ontology like the National Highways Corporate Ontology, sorry, this would be like the roads ontology, sorry, and then an institutional one like the NH Corporate Ontology, you can start to build knowledge graphs that feed LLMs. So an LLM, when you ask it a question, a large language model, you want to understand the intent, the institutional context, situational context, and that can all be drawn out of the ontology, combined with facts in the knowledge graph to build better answers and actions. We did some really interesting work with Avantra, a big SAP integrator. We're exploring this sort of stuff with Arup at the moment. It's quite an exciting area. I'm very happy to talk more about it later. And I see I'm at my 16 minutes, so I will say thank you very much, and I look forward to questions.
So first question, great presentation. How long does it typically take the client to get a usable ontology?
Realistically, I would give yourselves no less than 12 weeks to get something working. What you should be able to do in that time is get a simple ontology and connect it to two data models and demonstrate a lift and drop. That should be your proof of concept, if you like, proof of value potentially, if you can say, look, all of these extract, transform, load operations go away. It's not the only useful thing, however, you get in that, and we find a lot of the early use cases is people just going, oh, I've got all this stuff that I just hold in my head or is out in a spreadsheet or is out in a PowerPoint. Can we also join that to things in the data model? So again, that's kind of what you'd want to do in that first set. I think realistically, you'd then go through proof of concept, proof of value, pilot, rollout. That's going to be 12 months.
Good. Thank you. Next question is, Liam, fantastic presentation. You've outlined why interoperability is such a big challenge. What would you recommend to organizations or even sectors as the first step they should take towards achieving interoperability of their data?
So don't let perfect be the enemy of good. Start with the mess and sort of bring it in and start knitting it together. It can be knitted together badly. It's okay. Even just saying this over here is held over there is very useful. So a lot of the early work with National Highways was things like, can we just nail 30 work breakdown structures together to just show the differences? Or, hey, we seem to have a load of acronyms. Those all seem like important concepts, or why did we bother to say it so frequently that we have an acronym for it? Let's go bring those in. Well, suddenly you've got a set of concepts that you see cropping up again and again in your data models, in your enterprise architecture, things like that, ready defined. So yeah, I'd start there.
Brilliant, thank you. Next question, how does Ontology compare to other ways of visualizing and interacting and viewing ontologies? How else have you seen them visualized?
So the reason we built it was, I suppose, our dissatisfaction with the visualizations with Bloom for Neo4j or Protege's various visualization things, which are fine if you're looking at a small number of things. They very rapidly get very difficult to read as you're looking at a large number of things. So we wanted to bring the information architecture and information design specialisms from the world of multi-sector e-commerce into the problem of how do I visualize a whole bunch of stuff from a whole bunch of different perspectives all at once. And so there's lots of lessons you can learn from that, which I think a lot of the tools want to show you everything all at once. And a lot of the art is, what do you collapse away? What do you hide away? How do you make it easy to hold in your head? So there are other things you can do. Most of them tend to sit around the network view. So the very first one I showed you, that kind of balls and lines all connected together by elastic and settle into a network pattern. that's fine, but it's not stable and you can't start to memorize the landscape. So that's why we built it.
Very good. Next question is, what is the most impactful single action an organization can do to support their interoperability? Many are struggling to even get started because of the AI hype. So what's a killer action to start?
So if you remember that kind of radar graph I showed you at the beginning, that just kind of first step to say, what is the state of our current maturity? There are formal ways of assessing this, right? So there's some ISO standards. RSSB, as I said, are developing one for the rail industry, but that could be cheerfully used for any kind of transport modality. You kind of need to know what your baseline is, and the most important thing there is to say, what's my business case? So a lot of the semantic artifacts, like an ontology, why are you bothering? Because it makes it cheaper and lower risk to do interoperability. It doesn't mean you can't do interoperability. And so it's that balance of, do I do it once well for lots of opportunities of connectivity, or do I just do it once at a time as two data sets need connecting together, or an old system is migrating to a new system? Both ways perfectly valid. It's about getting the business case right in the first place, and that interoperability maturity assessment is a way of getting that in place.
Good. Our next question is, when looking to try and communicate this as a worthy investment, how have you established ROIs or return on investments that can be communicated to stakeholders?
Use case first. So don't start with, oh, we want an ontology. Start with, oh, we've got an interoperability barrier between either this system and that system, or the past and the present, or I've got, a giant and growing SharePoint of, 70,000 SharePoints that I need to bring under management, and that's costing me tens of thousands of pounds a month because I can't. So it's finding the use case first. A lot of the work we're doing with National Highways, which we're primed by GHD, the engineering consultancy, a lot of their work is actually around making sure, what's the problem, what's the cost of the problem, now let's go and find a solution, doing it in that order.
Very good. Next question is, how does this work compare with how the subject is tackled in other countries?
So I would say that we prefer a bottom-up approach, like philosophically. So we like to start with the mess and let definition emerge. This project is kind of the other way around, to say, how do we kind of just model reality and let people join to that? There's loads of really good European work. The European Interoperability Framework is well worth a look. And what they're doing there is building up lots of use cases, lots of business cases to say, look, here is a centralized ontology which we think is well worthwhile linking to. And here's how that helped us doing cross-border energy transfer in Norway. So bringing it through to that.
Very good. Last couple of questions. How do you manage changes in ontologies when implementing and mapping at scale? Are they meant to be backwards compatible?
So yes, quite a lot of work's gone into versioning. So we call it epistemic drift, so kind of meaning shifts over time. Sorry, technical terms there, but it's basically the what can we knows shifts over time. So yeah, there's what we do is any knowledge source is regarded as a work in progress with published versions behind it. So you in terms of backwards compatibility, use the fairly standard one to say, version 1.2 will work with version 1.1 and version 1, but it won't necessarily work with 0.5. Fairly standard software convention there. They are meant to be backwards compatible. The nice thing about an ontology is people think of it as abstract, but actually I see it as much more concrete. What you're actually trying to model is reality. And real world is the single source of truth here, and that doesn't change that much. So if you get it right, it's really a perspective on the real world that you're modeling. Ontology is not like data models, it's an open world, so you can add things to it trivially without breaking things off. And what you don't want to do is change the unique identifier that you're using for a concept, but we do quite a lot of work to make sure that even if you merge two concepts together, you've always got that provenance to say, if I type the old IRI, I get to the new one.